My name is Rex Chan and I work for HCL. I'm the worldwide tech support person for ITX. Today we're going to talk about how to install ITX container in a Kubernetes environment. To start with, I would like to talk about the three ITX containers available for customers. The first one is the IBM certified container. It's to be used with OPENSHIFT only. It is installed with OPENSHIFT operator. You can find the container image in the OPENSHIFT catalog. It is used for REST client to invoke ITX maps. The second one is the Red Hat certified container, and there are two of them. The definition of Red Hat certified is we have scanned the container code using Red Hat scan to make sure it meets all the requirements. They are both installed with HELM. Any Kubernetes that support HELM3 chart can be used. For example, AWS, Azure, or Google Cloud may have their own Kubernetes service. The first one is used for REST client to invoke ITX map. The second one is a replica of the launcher in container format. It allows you to reuse all your existing launcher assets, such as maps and MSD files. In this presentation, we're going to talk about only the Red Hat certified container that supports the launcher. The REST API server is covered by another video. The container installation module can be downloaded from Fix Central. It contains a full install. This container can be installed in any Kubernetes that support HELM3 chart. However, in this presentation, we will use OPENSHIFT as an example. As a customer, you should check with your IT to see what is used in your environment. As an IBM business partner, you can sign up for OPENSHIFT environment for 2 weeks at a time in IBM Tech Zone. Before you continue, I assume you have OPENSHIFT CLI or something equivalent, HELM, and Docker installed in your server. These are the tools to be used for installation, regardless of the Kubernetes environment. I also assume you have some experience operating in Kubernetes. The current version is 10.0.1.3. Check with support for the latest version. Download the file into your Windows environment. Unzip them to a new folder. There are 4 subfolders. The charts folder contains the HELM3 charts. The docs folder contains installation instruction in a Docker environment. The examples folder contains the map to perform installation verification. The image folder contains 2 content images, one for REST API and the other one for the launcher. Other than the docs folder, you should copy the other ones to your Linux server. The first step is to verify that you have access to OPENSHIFT or other Kubernetes service. Create a project called ITX Launcher. Although you can call it anything you want, but the example in this presentation refers the project as ITX Launcher. After you have created the project, return to your Linux server. To create a container image from the compressed file, use the docker load command. To making sure the image has been created, use the docker images command. You should see a new image being created. All these instructions, along with the rest of the presentation, are documented in a text file. If you are not able to download it, send me an email. My email address is in the first slide. You need to log into your Kubernetes environment. In this case, I'm using OPENSHIFT. If you don't know your login command, go to OPENSHIFT console, locate your ID in the upper right-hand corner, and choose the option Copy Login Command. After you logged in, you should see a response saying that you have logged in along with your OPENSHIFT ID. Since we'll be uploading the image in the OPENSHIFT, Let's switch to the OpenShift image registry project. A route allows you to access your OpenShift environment from outside. If you have a new cluster, it's possible that a route has not been created for the image registry. Create a new one with the OC create command. Once it's created, use the OC get route command to find out the route. The route will be used during the installation. If a route already existed, you don't need to create a new one. Once you have the route, you can use the Docker login command to prepare for pushing the image into the registry. The login command requires the route shown in the previous slide. You can see a message that says login succeeded. Before we can push the image to the registry, we need to tag the image. Replace the route with yours to making sure that the image has been tagged. Check with the Docker images command. Now we can push the image to registry. This process may take a few minutes to half an hour or more depending on the speed of your internet upload. For example, if you're not working in the office, it could take much longer. You can observe the speed of the process in real time. Once it's done, you will see a digest name. Copy this name to your notes as it may be needed for troubleshooting later. The next step is to prepare the HELM chart to replace the values for some default parameters. Most likely you will need some help from your Kubernetes administrator. Copy the charts folder and its content from the installation module you downloaded earlier. Extract them into the installation folder. You should see ITX LS charts folder. Make a copy of the values.yaml for backup purpose. Use an editor to modify some values in the values.yaml. The first change will be the storage class name, as it will be specific in each environment. This information usually comes from your Kubernetes administrator. Making sure that the class is read-write-many. This means you can run multiple pods across clusters for high availability if needed. The second change will be the run as user value. This is environment specific. If you're not sure what values to use, leave it as default. If the wrong one is used, the pod will not come up and the log will tell you what is the correct value to use. We're ready to install the container. Let's switch to the project ITX launcher. Make sure you are in a folder which contains the ITX LS charts folder. Issue the HELM install command. If the install is successful, you should see the status that says deployed. To make sure that the pod is up and running, go to OpenShift console. Make sure you're pointing to your project. Click workloads and then pods. You should have a status of running. If not, you can zoom into the deployment and check on events and then YAML. You should see some error messages pertaining to the failure. The next few slides will show you some common errors and how to correct them. After you have made the successful adjustments, it's a good idea to do a HELM uninstall before installing a new one. The install will clean up all the assets created by the install. The project will not be deleted. The first common error is the pool image cannot be located or the access has been denied. Check the digest value you copied earlier during the Docker push step. It should match with the one here. If it's correct, go to the OPENSHIFT console and click on Image Stream under Builds. Check to see if the values is similar to the one here. It should have the project name ITX Launcher and ITX LS as part of the name. If it looks fine, continue to the next step. It's possible that you need permission to access the image. This is where the secret comes in. You may have to create a secret for the entitlement key. In your OpenShift console, click Workloads, then Secrets. Click Create Image Pool Secret. Key in the values is shown on the screen. You can choose a name other than IBM entitlement key. In your values.yaml file, add the secret to the image section, save the file, uninstall the previous installation with HELM uninstall, reinstall again with HELM install. The next step is to verify that the container is working. Copy the map and MSL to the Linux server. The map translates input into uppercase. The MSL waits for the arrival of a file in a folder called Inputs under Data. Both the map and MSL are included in the examples folder. Let's switch to the ITX Launcher project to prepare for the testing. In order to copy the map and the MSL to the container, use the OC command. The first step is to locate the pod name and is needed in the OC copy command. Use this command to copy the map and MSL to the container. The map and MSL should go directly to persistent volume. That means they will not be erased even when the container goes down. It also means that they can be shared among multiple pods. The first step is to test to see if the command server is working. Go to OpenShift console, click on Workloads, Pods, and then Terminal to open a Unix console. Switch to the maps directory, write some text to a file, and then run the command server. When it's completed, take a look at the output file. It should contain words translated in uppercase. The next step is to see if the launcher is working properly. In the same Unix console, switch to the data folder and create two subfolders. One is called Inputs and the other is called Outputs. These folders are being referenced in the MSL. In order to pick up the new MSL, the launcher needs to be recycled. In the console, issue launcher shell stop command to stop it. Once it's stopped, issue launcher shell start command to bring it back up. You will see a message that said Docker mode blocked will block, and you can no longer key in another command. This is normal. It has to do with the entry point which is used to start a container. To find out more information, check the ITX release note available in the web. Another way to recycle the container is to restart the pod. Go to another tab such as Logs. Now click on Terminal again. It will bring up a new session so that we can continue. Switch to the input folder and create a file called input.txt by inserting some words in there. The file should disappear. Switch to Outputs folder. There should be a new file called output.txt. Review the content and you should see the words being translated into uppercase. You have completed installing the launcher container and verify that it's working properly.